So the average atomic mass is equal to mass into percentage abundance plus mass into percentage abundance. The mass is for first isotope and the second mass is for second isotope divided by 100. It depends upon the number of parts. For example, in the numerical, if we have given 10 parts, we will conclude it as mass into percentage plus mass into percentage divided by 10. Here is an example of oxygen. We have three masses of oxygen, means O16, O17 and O18. O17 and O18 are the isotopes of oxygen. So we have three percentage abundances. For oxygen 16, we have percentage abundance of 99.76%. For oxygen 17, we have percentage abundance of 0.04%. And for oxygen 18, we have percentage abundance of 0.20%. And we have total parts of 100. So we will multiply, add it and divide and get answer which is equal to 16 AMU. This is another example of chlorine. Find chlorine's average atomic mass if approximately 8 of every 10 atoms. It means we have only 10 parts, out of which 8 are of chlorine 35 and 2 are of chlorine 37. So the percentage abundance of chlorine 35 is 8 and the percentage abundance of chlorine 37 is 2. So according to the formula, average atomic mass is equal to mass of the chlorine 35. This is the 35 mass of chlorine into percentage abundance, which is 8, plus mass of chlorine 37, which is the 37 mass of chlorine. This is the isotope of chlorine, into the percentage abundance, which is 2 out of 10 parts. Here we are given the parts, so we are dividing it with 10. So multiply, addition and divide, we get answer 35.40 AMU. The next topic is chemical formula. What is a chemical formula? It is an abbreviation used for the full name of a compound with the help of symbols. In other words, we can say that the symbolic representation of a molecule of a compound is called as chemical formula. For example, the chemical formula of water is H2O. The chemical formula of sugar or glucose is C6H12O6, and for sugar it is C12H22O11. For sodium nitrate it is NaNO3. The chemical formula of a molecule shows the number of atoms of each element in the molecule. That how many number of atoms are present in a chemical formula. Formula consists of the symbols for the elements that make up the molecule, each followed by a number. If more than one atoms of an element is in the compound, for example water, we have 2 hydrogen atoms and 1 oxygen atoms. So in water, the 2 will be used as a subscript. Here there is an example of oxygen. In oxygen O2, 2 is used as a subscript. Similarly, we take an example of water, 2 atoms of hydrogen, so we use 2 subscript in place of hydrogen, and there is only 1 atom of oxygen, so there is no subscript at all. The next is empirical formula. Chemical formula is divided into 2 types, empirical formula and molecular formula. Empirical formula shows the simplest whole number ratio of an atom of the different elements present in a compound. An empirical formula shows the simplest ratio among atoms in a compound. For example, we have an example of benzene, which has formula C6H6. By placing the ratios, that is 6 and 6, 6 ratio 6, the 6 will cancel out the another 6 and we have the simplest formula CH. Similarly, glucose has the formula C6H12O6. Here 6 will cancel with 6 and the remaining 12, 6 is multiplied by 2 and 6 2s are 12. So the hydrogen get the subscript 2. So the simplest ratio of sugar or glucose is CH2O. For sugar, C12H22O11. You can calculate the empirical formula or the simplest ratio of sugar as well. Here is an example. The multiply subscripts from empirical formula by answer from step 2. We have molecular formula. Molecular formula shows the actual number of atoms present in a compound or a molecule. So the molecular formula is P4O10. By simplifying it, we will write as 4:10. Then 2 5s are 10 and 2 2s are 4. So we get 2 subscript of phosphorus and 5 subscript of oxygen. So the simplest formula or empirical formula is P2O5. Next is the molecular formula. Molecular formula shows the actual number of atoms of different elements present in one molecule of that compound. For example, the benzene have a molecular formula C6H6. There involves 6 atoms of carbons and 6 atoms of hydrogen. In glucose, we have C6H12O6. There involves 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. For the ionic compounds, the empirical and the molecular formulas are same. For molecular compounds, the molecular formula is the multiple of the empirical, that is, molecular formula is equal to N by empirical formula. C6H6 is the benzene. What is the benzene's empirical formula? 6 is cancelled with 6 and you have empirical formula of benzene is CH. Empirical formula is C2H3O2. How we can derive it? Look at the molecular formula. The molecular formula is C4H6O4 by writing the ratio 4:6:4. Then multiply it by 2. You will get the simplest ratio and that will be the empirical formula of that particular substance. Molecular formula. If you know the composition of a compound, either by mass or percent, you can calculate the empirical formula of a compound. By knowing the molar mass of a compound, you can find the molecular formula for the compound by following a few simple steps. The molecular formula is always a whole number multiple of the empirical formula. So, how molecular formula can be calculated? Here is a formula is given. N is equal to molecular mass by empirical formula mass, or we can write it as molecular formula is equal to N into empirical formula mass. Multiply each of the subscripts in the empirical formula by N to get the molecular formula. We can multiply the empirical formula with N and we will get the molecular formula. Thank you so much.